Let's start chapter 3, solving quadratics. This time, solving quadratics by square roots. What that means is eventually you're going to be taking the square root of something, right? And that's going to require you to have the ability to reduce those square roots. So we have a quadratic. It's not written in any particular form, and the reason why is because I have it set equal to a number. Okay, whatever. We just need to get x by itself. That is our job. And when something is written like this, getting x by itself is relatively easy. You're just going to use PEMDAS in reverse order. You're going to be using SADMEP. PEMDAS in reverse order. Whoa. That's how you get x by itself. SADMEP. So we're going to begin by doing addition and subtraction. Just trying to get x by itself. Good old Algebra 1 skills. So the first thing I'm going to have to do to get this x by itself is I'm going to have to move that 31. Add 31 to both sides, like so. 4x squared equals 80. Remember, your next test is no calculator. Hopefully you can add, subtract, multiply, and divide. Still trying to get x by itself. After SA, subtraction and addition, we move on to DM. No, not sliding into any DMs here. We're just working on the division and the multiplication. I got a times 4 here that I need to undo. I need this times 4 to disappear, so I will divide both sides by 4. X squared equals 20. Now we're on to EP, exponents and or parentheses. The last thing that we need to do to get this x by itself is make that power of 2 go away. So I ask you, what cancels a square? A square root. That's why they both say the word square. So you cancel a square with a square root on both sides. So you square root the left side, and you square root the right side. And this is going to happen. But something extremely important is going to happen. Because I canceled that square with a square root. Let me ask you a question. In last chapter, when you were graphing your parabolas, more often than not, how many times does a quadratic hit the x-axis? So if you have a U-shaped graph, how many times does it usually hit the x-axis? Twice. Yeah, twice. So the question becomes, if I just take the square root of both sides, I'm going to get the square root of 20, which we'll reduce in just a second, but how do I get my 2 answers? Because this is a quadratic. Where does the 2 answers come from? It comes from the fact that when you square a positive number, you get a positive number. And when you square a negative number, you also get a positive number. Canceling that square with that square root creates this plus or minus symbol, which means you have 2 answers, a positive answer and a negative answer. Plus or minus the square root of 20. All we have to do now is reduce this radical using the skills that we reviewed yesterday. Our job is to know the perfect squares. And you tell me, what perfect square can I divide 20 by? 4. So, all right, well, plus or minus the square root of 4 times 5. You can't take the square root of 5. That number is stuck. But you can take the square root of that 4. So you will take the square root of that 4. It comes outside. Plus or minus is still here. Square root of 4 comes out. It is 2. Root 5 is stuck. Your 2 answers are x equals negative 2 root 5 and x equals positive 2 root 5. It is 2 different numbers. And there it is. Yes, sir?
So if you can't get a negative number through square rooting, then how can you also have that?
Well, let me ask you a question. What is 2? Let's not do 2. What is 3? Come on. Oh, look, we're crashing. Okay, good. What is 3 times 3? 9. Great. What is -3 times -3?
9.
Oh, there it is. So if I said to you, some number squared gave me a 9, you couldn't just tell me the answer was 3. It could also have been -3. The reason why is because a square hides negative results from you. You don't know. X could have been positive or negative. Now, can I take the square root of a negative number in the real numbers? No. But if I square a negative number, I will always end up with a positive. And that is why we're having to say plus or minus. If I just say, what's the square root of 9? Your answer is 3. That's it. Well, hey, what's the square root of 9? 3. But if I say, hey, x squared equals 9, what are the possible solutions? 3 or -3. Because I specifically said it's x squared. When you just say a square root of a number, like square root of 16 is 4, what you didn't know is that you're actually giving what we call in mathematics the principal root. Technically, when you take the square root of a number, there's a positive and a negative solution. But we don't say the negative thing if I'm just saying, hey, what's the square root of 25? Well, the answer is 5. You give me what we call the principal root or the principal solution. But if I say x squared equals a number, you're going to have a plus or a minus. You don't have a way around it. Because canceling a square with a square root is going to show you the plus or minus every single time. So that one's relatively straightforward. You're just, handling sad MEP. All right. Now this one, slightly different. This one you have vertex form equaling some number. The good news is you could still solve this using sad MEP. It's not a big deal. We need to isolate our x, following PEMDAS in reverse order. So first we work with our addition and subtraction. I'm going to need to add 11 to both sides. Are one of those windows open back there? Why is it so loud? Are they closed?
Yeah, it's close.
Oh my goodness. Sounds like they're running a leaf blower or weed eater right outside my window on the 3rd floor. Oh, you're right. I bet you it's extremely loud on the 1st floor. I didn't even think about that. And now I'm thankful I'm on the 3rd floor. Suck it, 1st floor. All right, -47 plus 11 is -36. Now we move on to DM, division and multiplication. This is a multiplication. We will cancel it with the division. So you divide both sides by -3. Just like multiplying two negatives, dividing two negatives is going to give you a positive result. So basically, you can think of the negative signs as canceling each other, like that. And then you say, what is 36 divided by 3? 12. Remember, your next test is no calculator. You need to be able to multiply and divide. Now we're on to EP. Exponents and or parentheses. The x is buried inside a set of parentheses. I cannot get that x by itself until the parentheses are gone. But what's creating the parentheses is the exponent of 2. So for this one, I'm trying to peel this onion from the outside in, right? I had to work on the layers from the outside in. So I actually can't do anything with the +2 right now. It's being protected by the exponent. Therefore, I must cancel the exponent before I can make the parentheses go away. You see, now the parentheses will disappear. They don't have a purpose anymore. Yes, Sam? You cannot distribute an exponent. It doesn't work that way. X plus 2 quantity squared does not mean x squared plus 2. X plus 2 quantity squared means x plus 2 times x plus 2. And you'd be forced to FOIL like we did back in Algebra 1. So you must cancel the exponent with a root, okay? So we take the square root of both sides. Canceling a square with a square root does the same thing this time that it did last time. Creates a plus or minus symbol on the right side. On the left side, the parentheses only existed because of the exponent. Now that the exponent is gone, the parentheses are no longer necessary. Trying to get x by itself. So, got to get rid of the plus 2. I'm going to subtract 2 from both sides. Now here's the thing. It is not underneath the square root bar. That means it is not like terms with that root 12. The way we do these in mathematics is we put the number in front of the plus or minus. So what it says is x equals negative 2 plus or minus the square root of 12. And we're not, yes, Nick? I just subtracted 2 from both sides, and instead of saying plus or minus root 12 minus 2, I just said minus 2 plus or minus root 12. Yeah, so we're just moving it to the other side, and you want it in front of the plus or minus symbol. And we're not quite finished yet. We do still need to reduce that radical, because there is a perfect square that I could divide 12 by. I could divide it by 4. It is 4 times 3. The very last thing you're going to do is take the square root of whatever you can take the square root of. And you can take the square root of that 4. It gets to come out. The square root of that 4 is a 2. But the 3 is stuck. That is 2 different answers. That is x equals negative 2 minus 2 root 3, which are not like terms, so I cannot combine them, and x equals negative 2 plus 2 root 3. 2 different solutions. You might be wondering what this means. I mean, negative 2 minus 2 root 3, negative 2 plus 2 root 3. What does that even mean? Well, what's the most important thing that we know about a parabola from chapter 2? Most important thing, the one thing that I said, we're very happy that parabolas have this property. They're symmetric. Symmetric around what? Well, vertex, but more specifically the axis of symmetry, right? Yeah. You see, parabolas are symmetric around the axis of symmetry. That means if a quadratic crosses the x-axis twice, and by the way, the parabola I'm drawing right now is not, actually, let me do a better job. Come on, I hit undo. What is this thing waiting for? There we go. This could be the graph of the parabola that we just solved for x. Its 2 x-intercepts are negative 2 plus 2 root 3 and negative 2 minus 2 root 3. The axis of symmetry goes right through the middle. Guess what number is directly in between those 2 crazy x-intercepts? Negative 2 is. You see, that's why we say negative 2 plus or minus the 2 root 3. You're literally saying this parabola is centered around x equals negative 2, and its x-intercepts, its solutions, are going to be the distance 2 root 3 to the left and 2 root 3 to the right. That's what that says. So these solutions tell you where your axis of symmetry is and tell you how far away your answer is. This green distance right here is a distance of 2 root 3. And so is this distance. It's just the other direction. That's what these solutions mean to the graph. It means your graph is centered around x equals -2, and your solutions are the distance 2 root 3 to the left and right of that number. That's what that tells you. So when you were using the quadratic formula in Algebra 1 and you got answers like this, you didn't understand what they meant, I'm assuming. You were just like, okay, there's my answers. Woo, yay, I solved for x. But it's important to me that you understand what those answers mean. The answers are telling you where your axis of symmetry is and how far away the axis of symmetry is from the two solutions. Cool with that? No? Okay, well, regardless of whether or not you're cool with it, since nobody's talking to me, I'll just move on. I would like to caution you to falling back into Chapter 2 habits of completely not interacting with me. We all saw how that worked out. And I don't plan on cutting the ends of chapters off and remediating a week every single chapter. I'm not going to keep doing that. At some point in time, we are going to have to learn from our mistakes. So I ask you, please be an active participant in your education, wonder about what's going on, ask me questions, and talk to me. All right. Let's keep solving for x. This first example, someone want to tell me what I'm going to have to do first, trying to get x by itself? What do you got for me? Yeah, you got to divide both sides by 2 first. I can't distribute this 2 because the exponent. Instead, I divide by 2 on both sides. This gives me x equals, whoops, sorry, jumping the gun here. X minus 3 squared equals 25. Next step. Somebody else, somebody new, somebody not junior. Okay, what do you got for me, Lewis? Square root both sides. Yeah. And since you told me that, Lewis, what is that going to give me on the right side of the equation? Yeah, like just tell me what to write on the right side of the equal sign. What's the square root of 25? Okay, so is the right side of this equation just going to have a 5? Don't forget that plus or minus. Because I'm canceling a square with a square root, I must have a plus or minus symbol. Now our last job, obviously, is to get the x by itself, so add 3 to both sides. Let me tell you what you're not allowed to do. You're not allowed to say the answer is plus or minus 8. Do not do that, because that's not true. Take the time to write it like this. Please. Please take the time to write it like that. This way you can see what your two answers are. Your answers are x equals 3 minus 5 and x equals 3 plus 5. So -2 and +8. Students have a very bad habit of trying to add that 3 to that 5 right here. You can't do that. I just showed you why. Because it's two different numbers. It's +5 and -5. So you're adding 3 to a +5 and you're adding 3 to a -5. That's why. So if you called it plus or minus 8, which by the way is a wrong answer waiting for you on my test, you get half credit. I mean, at least I know that you knew how to solve by square roots. You just goofed up the end. But you don't want half credit. You want full credit. So please just take the time to write it as two separate numbers and then combine them if possible. Yes, sir. Oh, the 5 was the square root of 25 up here. Yeah. Remember yesterday when we filled out the chart? With 5 times 5 is 25. Yeah, so the square root of 25 is just 5. What does this tell us, if you cared, as far as the graph is concerned? Well, this is vertex form up here, right? Its axis of symmetry is at x equals 3. it crosses the x-axis 5 to the right of the axis of symmetry and 5 to the left of the axis of symmetry. Lewis, I don't know if you remember, but back when we were doing intercept form of quadratics, when we were plugging in our axis of symmetry x, you asked me a really profound question. You asked me if after I plug in my x, if the numbers inside the parentheses would match, just one positive and one negative. And I said yes. This is why. They match because your axis of symmetry is the same distance from both roots, solutions, x-intercepts. That's why that's happening. Our axis of symmetry is at x equals 3, and you go to the left 5 and to the right 5 from the axis of symmetry to figure out where you cross the x-axis. So -2, +8. Bless you. I like how he took his mask off to sneeze. So why do we wear a mask? Just breathing? So how do you think spit goes farther? Coughing, sneezing, or talking? Coughing and sneezing, right? So the one reason we wear a mask is to protect us from people's coughs and sneezes, and yet everybody has a habit, not just you, everybody has a habit of removing the mask to cough and sneeze because, I don't want it inside my mask. And what's the point of wearing them, right? I know. I'm not saying I get where you're coming from. I'm just saying it's like, but you know how we avoid that? We should all be wearing the paper masks. And if we have to cough or sneeze, toss it and put a new one on. Just be wildly wasteful. Which you can see I'm not wearing a paper mask. I'm just making a comment. Okay, so my wife and I had to talk about that yesterday, literally yesterday. This one. Let's see. I'm just gonna start calling on random victims. Hey, I'm already talking to Graydon. Graydon, what would you do first on this one?
You would divide by 6.
There we go. Subtract 1 from both sides. So we have 6, and then x minus 4 squared equals 24. Kevin, you're next. What would you do now?
Divide by 6.
Now we move on to DM. Now we divide by 6. So you're trying to peel the onion from the outside in. Peeling the onion. See, just following Mr. Jackson's suggestion. Mr. Jackson's suggestion was to just call on random people, spot checking people. So Samantha at home. Hello, Samantha. Good morning. What would you do now?
Square root them.
Awesome. Thank you, Samantha. Appreciate you. Yeah, we're going to square root both sides. See, the Zoomies didn't think that it was coming their way, did they? They're like, nah, we definitely safe. On the left side, I have an x minus 4. As a class, I would like you to tell me what do I have to remember to have on the right side? Class, lots of people say it. Plus or minus. 2, 3, or 4 of you said it, but yeah, plus or minus. Canceling that square gives me a gives me a plus or minus every single time. And Dalen just showed me what the square root of 4 is with his fingers. He says it's 2. I absolutely agree. Boom. Now, when you add 4 to both sides, you are not going to say plus or minus 6 because that's wrong. That's going to give you half credit. What you're going to do when you add 4 to both sides is put it in the front. And you're going to take the time to write it as 2 different statements so you get full credit on this question. It is 4 plus or minus 2. Your axis of symmetry is at x equals 4. There's an answer 2 to the left of that number and 2 to the right of that number. 2 to the left and 2 to the right. There they are. What's up? I'm glad you think it's easy. But when we were in last chapter, did you think graphing vertex form was easy when we did it? No, but it was easy, right?
No.
Yes, it was. And then, yeah, it was easy, right? Until I taught you all the forms and said start graphing. Mm-hmm. Same thing is going to happen in this chapter.
I have a question.
Who is talking? Yes, Samantha, what can I do for you?
So on the test, instead of it being plus minus, would it just be like x equals 2 and 6, or just one of those?
No, it would have to be both of them.
Both of them. Okay.
So I wouldn't say x equals 4 plus or minus 2. I would say x equals 2 and x equals 6.
Okay.
Yeah. Now, if it was like the first one, the -2 plus or minus 2 root 3, it might say it like that, or I might write it as two different numbers, but that's only because I can't combine them. If I can combine them like I could on this slide, I expect you to combine them. Okay? Yes, Junior. The 2 and the 6 are coming from, so you were cool here, right? Right. So I wrote this as two different things. I wrote it as 4 plus 2 and 4 minus 2. Because it is two different answers. Lots of colors right there. Other questions on that before we move on? These are good questions. You guys got to ask. Got to get your questions answered. Oh, I heard somebody say there's fractions. There must be fractions on the next one. Yes. Yeah, those are the x-intercepts. That's what solutions mean. When you were in Algebra 1 and you were solving quadratics, you were supposed to understand, and this is not me saying anything poor about our Algebra 1 teachers, but you were supposed to understand that when you solve for x, you're actually figuring out where a graph crosses the x-axis. And that's true for any time you've ever solved for x in your life. Anytime you've ever solved for x, you have figured out where something crosses the x-axis if you were graphing. Now in Algebra 1, nothing had exponents. So what you were really doing was talking about straight lines, where are straight lines crossing the x-axis or where are straight lines crossing each other, things like that. You were always finding the x values of where things are crossing things. So when you are solving quadratics, you are figuring out where they cross the x-axis. You're literally trying to figure out where they equal 0. You're finding the zeros. You know that's one of the Algebra 1 standards for the FSA is that a student understands that solutions of an equation are x-intercepts. That's one of the standards. And it's such an easy thing to understand, but it's almost like you need to be explicitly shown it. All righty. Let's go ahead and write SADMEP up at the top of this one. Cool beans. So needing random victims, let's see, people that don't normally talk to me. Caroline, good morning. Can you tell me how to start this one? Perfect. Add 10 to both sides, she says. Thank you, Caroline, I appreciate you. So we're going to add 10 to both sides. It's going to give me 3x plus 6 squared equals 90. Yes, ma'am. Yeah, square root both sides. So Nadia says to square root both sides. Nadia, what's it going to give me on the right side? Like, what do I have to have? Yeah, what must? There it is. So I have to have that plus or minus because I canceled a square. Great. I wasn't asking you to reduce. Just we'll get to that in a second. On the left side, we have 3x plus 6. Okay. Can I make a suggestion? Reduce your radical first before you continue getting x by itself. See, reducing the radical has nothing to do with SADMEP. It's going to have to be done before you're finished anyway. So I would suggest doing it now. It's going to make your life easier. Let's tackle that. There is a single perfect square that I can divide 90 by. 9, yeah. I can divide 90 by 9. So we're just going to leave the left side alone for now. Plus or minus, and then 90 will be 9 times 10. Well, I can't take the square root of 10 without a calculator, but I can take the square root of 9. That number is going to come out. Square root of 9 is a 3. The 10 is stuck, though. Boom, stuck. Get off that phone, Graydon. I don't care. There's 2 clocks in my room. And they're both accurate. I changed them both on Monday. There for me and there for you. Also, you have your own, don't you? And there's one on the computer screen, too. Okay, so now that our radical is reduced, now we're going to go ahead and finish solving for x. We're going to continue to follow SADMEP. What do I do now? Jay Sean, if you don't mind, only because I never get to hear your voice, what would you do at this point? trying to get x by itself following SAD-MEP. Don't look at anything before. If I just handed you this right here on the left side, what would you have to do first? Because you have two things, right? You've got this. Hold on, wait. Hold on. I pressed undo one too many times. Right here, hey. Right here, Jay Sean, I have a multiplication. And right here, I have an addition. Following SAD-MEP, which of those two do I have to deal with first? Yeah, I'm going to have to deal with the addition and subtraction first on that side. You see, that's why I said I don't want you to just... SAD-MEP is it's a guide, but it's not a 100% law. You two are killing me. Once again, once the parentheses are gone, now we're just looking at that side by itself. And I go, okay, on that side, I've got a multiplication. I have an addition. SAD-MEP tells me which one I have to deal with first. And yeah, I'm going to have to subtract. I'm going to have to deal with the addition first. So let's subtract a 6 from both sides. Just like I did the last time we had to subtract and there was a radical over there, I'm going to put that number in front of the plus or minus symbol. And now this is where I'm allowed to divide. I mean, that's clearly the last thing I need to do. I'm dividing both sides by 3. But what does that mean on the right side? Because there's a lot of objects over there. There's technically 2 different things over there. They're separated by plus and minus, but there's 2 objects. And if I divide the side by 3, I'm dividing the individual objects by 3. So technically, I'm dividing everything by 3. So divide this by 3, divide this by 3, just like that. On the left, x is lonely now. Necesito más espacio. See, x equals. Now, negative 6 divided by 3 is negative 2. But check this out. 3 divided by 3 is 1, so those are just gone. And I'm left with root 10. This is 2 different solutions. And it might be written like this on the test, or it might be written separated. Negative 2 minus root 10, and negative 2 plus root 10. This tells you that your quadratic has its axis of symmetry at x equals negative 2. It crosses the x-axis, square root of 10 to the right of that number, and square root of 10 to the left of that number. Yes, sir, Junior. Yeah, I might write them as a combined answer or as a separated answer. Now, if you remember the last examples, my answers were whole numbers. If the answers can be whole numbers, or not, let's not even say it like that. If the answers can be combined into a whole number or a decimal, I want you to do that. Like, for example, these 2 back here. These 2 back here got me, what was this one? This was 3 plus or minus 5. Well, you wouldn't leave it like that, you know? Why? Because they're like terms, that's why. So you would say, oh, this is 3 minus 5 and 3 plus 5. Because they're like terms, I would expect you to combine them in the 2 different ways. Yes, Liz? Yo, yeah. I didn't clear anything. I just wanted to make sure we would clear that. If they are like terms, I expect you to combine them. How would you graph it? Well, it's not a pretty number, and that's why I'm not asking you to graph it. I don't know if you noticed, but when we were graphing our quadratics, if we ever had x-intercepts, it was coming from intercept form, right? And they were pretty. These are ugly. That's why when we were doing vertex form, I never asked you where does it cross the x-axis. Because normally, vertex form is going to give you ugly answers. Not always, but normally. That's specifically why that was not part of the graphing when I was doing vertex form. I asked you to find me the vertex and use my fraction trick on the front. Because I knew that that would always work. Finding x-intercepts, well, no. And that was also how I was identifying people that were cheating on the homework. It's like, okay, you found x-intercepts. Yeah, I never taught you how to do that. And you don't know how to graph negative 2 plus root 10, you know? So. All right. Oh, God, a fraction. Okay. Who never talks to me? Who never talks to me? Casey, I don't even know what your voice sounds like. Casey, what would you do with this one? How would you start it?
If you distribute the 1/4, that's negative.
Now, let me ask you a question. On either one of these examples, did I distribute that number?
I think so.
I'm sorry?
I don't remember.
Well, look at your notes. Did I distribute that 2 or did I distribute that 6?
Yeah.
No, I didn't. Both examples. Uh-oh. I didn't distribute those numbers at all. You need to follow SAD MEP. So following SAD MEP, what would you do first?
Square them.
Hmm?
Square them.
No.
Right now.
This stands for addition and subtraction. So which one? What would I have to do first?
Subtract.
Right. So we're going to subtract this 2 from both sides. Thank you, Casey. Appreciate you. Let's make sure we're taking good notes. Now, Kevin, you seem to be, I'm not sure if it was you or your partner in crime over there that was concerned about the fraction, but here we have a fraction. Negative 1/4. Well, I'm asking you. So negative, I've already picked on grading today. Negative 1/4. And when I did, you laughed at him. So now it's your turn. Negative 1/4. I need it to go away, but the last thing I want you to do is try to divide by a fraction, because there's a really good chance that a lot of you aren't good at dividing by fractions. So Kevin, do you know how to cancel a fraction? It's okay for you to say no. No? Let me ask you a question. What is 1/4? Tell me another way of saying 1/4. No, not as a number. Just tell me another way of saying it. A quarter. Hey, Kevin, how many quarters makes a dollar?
4.
Ah, so if you had 4 quarters, it would equal to 1?
Yeah.
Okay. So if you wanted to cancel a 1/4, you would just multiply it by 4. You see, anytime you want to cancel a fraction, grading, here. Anytime you want to cancel a fraction, you multiply by whatever number is on the bottom. If you multiply by whatever number is on the bottom, your fractions will disappear. I'm sorry? No, I said to make the fraction go away. That doesn't mean it'll make everything go away, just the bottom of the fraction. So it just makes the bottom go away. Well, you know what you could do? Yes, the -1 is still there if you multiply both sides by 4, but why don't we just multiply both sides by -4? What happens when you multiply 2 negatives? Oh, yeah. So now this equals +1. Now there's nothing in front of those parentheses. Anytime you want to cancel a fraction, you multiply by whatever's on bottom and the fraction will disappear. But it's only going to cancel the bottom of the fraction. You might still have the top. Like this one here, we're still left with a 1. I don't need to write the 1. I could, but I don't need to, so I'm not going to. Oh no, Mr. M, you said it's a no calculator test. Whatever will I do? Well, you'll learn how to multiply, or you could do it by hand, doing the whole carry method and whatever. Or you could just know that 16 times 4 is 64. That would be great. You know why I want you to know that? Because I asked you to memorize some multiples of perfect squares, and oh, that's right, 16 is a perfect square. Now, last thing we're going to do is well, not last thing. The next thing we're going to have to do is cancel the square with, someone said it, square root. Bloop, square root both sides, which is going to create the plus or minus. I don't know if you guys noticed this, but every time I crossed out that exponent of 2 with a green line, I used green to write the plus or minus, trying to really embed that. Yes, Ben. Yeah. I'm sorry? Do you know how to divide by 1/4 without a fraction? It is? How? Huh? How do we divide by fractions? What? No, it's 64. 16 divided by 1/4 is 64. Yeah, 16 divided by 4 is 4. I said 1/4. You see, and that's why I'm telling you, you're going to want to do it this way because dividing by fractions is probably something you forgot to do. By the way, you use that whole keep, change, flip deal when you divide by fractions. Remember keep, change, flip?
Yeah.
Right. So either way, you're going to end up doing 16 times 4. Okay. Lewis, question for me? Yeah. Yeah, that's all it is. Just multiplying both sides by 4. Hey, what's the square root of 64, guys? 8. Sam knows. There, somebody at home hot mic'd, but then shut it back off because Sam was fast. But yeah, it's 8. Oh boy. Let's see. Who haven't I talked to? I haven't talked to some Zoomies. Ryan, what would you do next, sir? Follow side map. You got 2x plus 6 over there. Which one are you going to get rid of first?
The 6.
Yeah. So we're going to subtract 6 from both sides. And just like I was doing before, please don't try to subtract that 6 from the 8. Write it in front of the plus or minus symbol, guys. It's worth the time. It's going to save you headaches. You're going to get right answers if you do it the way I'm asking you to do it. It wouldn't say 6 plus or minus 8 because those are, you can combine those because they're like terms, so I would never do that. Now, at this point, what I did in the last question was I divided, right? Could I, right now, combine those and get 2 different answers and then divide? I could. It doesn't matter which option you choose. It really doesn't matter. So I could either divide both sides by 2 right now, which means divide everything by 2, because that's what you saw me do here on the left. Or I could say 2x equals negative 6 minus 8, and 2x equals negative 6 plus 8. It doesn't matter. You will get the same answers either way. What do you think is better to see? Want to divide right now because it matches the one on the left? Let's divide everything by 2. X equals negative 3 plus or minus 4. That is 2 answers. X equals negative 3 minus 4. And x equals negative 3 plus 4. That means x equals negative 7. And I hear lots of zippers. Doesn't this class get over at 9:21? Oh, that's Friday. Oh, the bell's about to ring. Well, good thing I just finished the notes. Boom. There it is. Mic drop.